Christiaan, I think the floor is yours now.
All right.
Thanks, Simon. I'll try to keep it maybe short, but I think we had a really good example of how there's a good roadmap for a big sustainability opportunity up to 2030. What I want to focus on today is something that's potentially more short term, which is optimizing for sustainability. And what I absolutely love about optimizing is that it doesn't just address one thing, because what we're optimizing for is minimizing fuel burn. But at the same time we minimize fuel burn, we also minimize cost. And most of the times what we do to optimize is actually increase flow, which again also positively impacts airport capacity. So I think it's a really cool way to think about sustainability with a lot of other benefits on the side. So let's go through a couple of examples. The first one being the connection of preconditioned air and ground power units. Because one of the things that's important to keep in mind, if you want to optimize, you need to know what's happening. If you don't have visibility, if you don't have data, if you don't have knowledge, it's very hard to optimize because you're basically driving with your eyes closed. So first of all, what we want to do is as an aircraft arrives to the stand, we want to have the PCA and GPU connected as quickly as possible to minimize fuel burn of the aircraft on main engine or APU. And at departure, we want to disconnect these devices as late as possible before the actual departure of the aircraft. Now, if you have real-time data about connections and disconnections, you can actually monitor this, and if it's falling behind, if you spot a trend over time or spot a trend for a certain handler or a certain airline or a certain position, you can act on that. But also in real time, if you see that an GPU is not connected, within a minute after the aircraft arrives, you can send out an alert to whoever is handling that aircraft to make him do so. On the other side, if we have data about the aircraft and we can actually predict when the aircraft is going to be ready for off-blocks, we can use this information that is typically much more accurate than the target off-block time that ground handlers set today. You can much better determine what is actually the moment when you should detach the GPU and detach the PCA and ask the pilot to start the APU. So I think that's the first way where we can optimize by having more information about what's actually happening on the stand. The second thing I want to talk about is optimizing departures. What we often see as passengers, but also from a business perspective, is that your aircraft is actually cleared to be pushed back, and you taxi to your runway, and then you end up in a queue. And sometimes this is a very short queue, but this can sometimes also be quite a long queue where you can end up waiting up to 15-20 minutes sometimes. At that time, you're just burning fuel. And sometimes this queue is a coincidence, but sometimes it's also intentionally there to basically let air traffic control maximize the runway capacity. The reason why they put the planes physically there is because they know the off-block time information that they have is not accurate enough to rely on to build a virtual queue. So again, going back to increasing visibility and increasing data and knowledge and making these off-block time predictions more accurate, you can build a much better virtual queue and give the aircrafts the pushback clearance, taking into account variable taxi times to make them end up at the runway at exactly the same time, so not sacrificing runway capacity in exchange for this sustainability gain that you can win. Can you make the next slide, please, Simon? Thank you. So what about arrivals then? Because the same phenomena, aircraft waiting, aircraft holding, also happens on arrivals. And there's typically two situations in which this happens. First of all is that when the aircraft lands, the gate that the aircraft is supposed to go to is not ready yet because the departing flight that was on this gate or stand is still standing there because it's delayed. One could ask themselves, why has the gate planner then not replanned the aircraft to another stand? And typically this is the case because the information that the planners use, again, comes from the ground handler, which is the target off-block time. And typically the ground handler either doesn't or updates the target off-block time very late, which doesn't give the stand planner a lot of time to be proactive and reschedule the next flight to another stand. So again, to have an automated target off-block time that is continuously calculated and is more accurate, allows stand planners and gate planners to be more proactive in their job. So it's a great tool for them to make sure that they can, reroute incoming aircraft and make sure that they're not holding and burning fuel on the apron somewhere. The second situation that we see, and it's also the situation you see in the KLM movie here, is that sometimes ground service equipment is left on the stand. It's not parked in the right position. Sometimes the bridge is not fully retracted, or there's another cause for the stand not being ready to receive the incoming aircraft. Now, in the best case, either the pilot or the ground handler spots this, and they make the aircraft wait until the GEC is taken away or until the bridge is fully retracted, and then the aircraft comes onto the stand. Again, it's burning fuel. It's an inefficiency that we can take away if we can actually spot the ground service equipment being there or the other thing that's basically blocking it. Worst case scenario, of course, is if they don't see the ground service equipment or they don't see that the bridge is not in the right position, they taxi in that they actually hit the bridge or hit the GSE, which is then a safety incident that we of course don't want. Lastly, another very interesting situation that is partly addressed by ACDM, especially in the European airports that share their ACDM information with the network manager, is optimizing arrivals. And the idea here is that for any airport that is receiving incoming planes, you can calculate when do these planes actually arrive at the airport. And back in the day, of course, we had these waiting lines or stacks of aircraft waiting in the air, which is probably the worst place to wait because they're burning a lot of fuel. So already in the ACDM framework, what they're trying to do is determine the startup approval time of the aircraft on the originating airport based on when it's going to arrive at the destination airport and how that's then going to fit in with all the other arrivals that are arriving at the same time. Again, building this virtual queue, which does not require any physical holding of the aircraft in the air, but basically a virtual queue which makes each aircraft arrive sort of on demand and just in time. However, this entire exercise, again, depends on when is an aircraft actually ready, the target off-block time, as that is exactly the kind of information that the network planner takes into account to calculate when the aircraft could take off and actually arrive at the airport. So it's actually brilliant that the entire framework, the entire system is already there. And by increasing the input data into these kind of frameworks, we can actually make sure that we improve something that's actually already there. And again, reduce aircrafts holding in the air and burning fuel unnecessarily. So thanks again. That's basically what I wanted to share, where we see potential for optimizing for sustainability by having more accurate data about what's happening in your operations and be in better control of them. And very happy to move on to the Q&A session.
All right. Whoops. Piotr, can you please go? Thank you very much. Thank you very much, Chris. Thank you very much, Dirk and Simon. Robin, it was really a very nice presentation of you all. So just to summarize and to give you some of the key takeaways, basically when you look at how you actually achieve aircraft ground operations sustainability, I think one of the key messages that Robin shared is that real change can only be achieved by working together, by collaboration. This will also lead to some form of change management, which is important to break these old habits. And in addition to this, you have to use modern technology in order to get enough data for the analytics part, but also, like in Schiphol, to actually change the way stuff is done today. So in Amsterdam, we saw that the operational test with the taxi bot is a great move into the right direction. Schiphol is definitely leading the way to sustainable taxiing here. But again, coming back to Robin's statement, the scalability of sustainable taxiing can only really be achieved in close collaboration with the whole aviation sector. And then last but not least, that AI-based optimization is required to improve the underlying processes and also the engagement standards, so that even if you move onto new technology, if you don't change the underlying processes, you only reap half of the benefits.